All right, let's try this again. So this is attempt number 2 at this. This is the solution guide for optional homework number 4. Our first case is a solution of lactic acid and sodium lactate that when put together have a pH of 3.51. Our goal is to determine whether we have more acid, more weak base, or equal amounts of both in solution. We're given the Ka value, so we're going to find pKa by taking the negative log of Ka. So we're going to take the negative log of 1.38 times 10 to the negative 4th. That happens to equal 3.86. Since our current solution, 3.51, is less than 3.86, this must have more weak acid. Our second solution, we were given a pH of 8.7 and a Ka value of 2 times 10 to the negative 9th. So once again, we're going to go ahead and find pKa, which is the negative log of Ka. pKa is 8.7, so since pH and pKa are equal to one another, we must have the same amount of both. Okay. Then our third solution, number 3, we have pH of 4.6. We have a Ka value of 6.4 times 10 to the negative 5th. So yet again, we're going to find pKa by going ahead and taking the negative log of 6.4 times 10 to the negative 5th, which is going to be 4.19. So since pKa equals 4.19, 4.6 is a higher number than 4.1, obviously enough. So this time we must have more weak base. Okay, number 4, we are given a pH of 9.25. Our Ka value is 5.56 times 10 to the negative 10th. So we are going to take the negative log of that. We find that pKa for this particular combination is 9.25. Since once again they are equal, pH and pKa are equal to one another, we must have the same amount of both. All right, and then finally, in number 5, now when I initially issued this document, unfortunately, I did forget to include a pH of solution in number 5. That was my error. Somebody pointed it out, and some of you may have seen I did make an adjustment, but if you didn't see that, it was intended this was going to have a pH of 10.3. Now this time we are given Kb instead of Ka, so our first step is going to have to be to find Ka, which is going to be equal to 1 times 10 to the negative 14th over the Kb value that we've got. So we need to go to the calculator here, and that's 1 times 10 to the negative 14th divided by 4.38 times 10 to the negative 4th. So our Ka value is 2.28 times 10 to the negative 11th. We go ahead and take the negative log of that, and we find that pKa is 10.6. Since 10.3 is less than 10.6, this must have more acid. It is perfectly possible for us to have a solution containing nothing but weak acid and weak base that has a pH above 7, but still has more acid. It just means that the acid is much, much weaker than the base is. All right, hopefully this recording worked.